Calculate slope from tables. This is part 3 of 6 videos about slope, which is also part of the Family of Functions series. You may need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. What we want you to be able to do is, given a table of ordered pairs for the graph of a relation, decide if the relation is linear. And if it is linear, calculate the slope of the line. So here's our first example. Since slope is change in y over change in x, we need to calculate the change in y and the change in x. Remember that change in y is found by subtracting the y values. So in this case, I'm going to subtract 7 minus 4 and get 3. So the change in y is 3. The next one, 10 minus 7 is 3. 13 minus 10 is 3. 16 minus 13 is 3. Notice I'm going bottom minus the one above it, always in the same order. The change in x is found by subtracting the x values in the same order as I did the y values. So would I subtract 1 minus 0 or 0 minus 1? The answer is 1 minus 0 is the change in x because we went bottom to top. So calculating the other change in x's, in each case the change in x is 1. Now we need to calculate the slope for each corresponding change in y over corresponding change in x. And so for the first one, it will be 3 over 1, 3 over 1, 3 over 1, and surprisingly 3 over 1. Since the slope is the same for each pair of points, the relation is a linear relationship, and the slope of the line is 3 over 1, or just positive 3. Example 2. Again, slope is the change in y over change in x. We need to calculate both the change in y and the change in x. Change in y is found by subtracting the y values. So in this case, we'll do 4 minus 7, which is negative 3. The change in x is found by subtracting the x values in the same order. So for our change in x for the first two ordered pairs, it would be negative 2 minus a negative 4, which would be negative 2 plus 4, which is positive 2. So what we'd like you to do is copy the table above and calculate the remaining change in y and change in x. Press pause as needed and resume when you're ready. So we found the change in y is to be all negative 3. The change in x is all to be positive 2. Press pause as needed in case you need to check any of those. Now calculate the slope for each corresponding change in y and change in x. Pause as needed, resume when you're ready. And negative 3 divided by 2, in each case, negative 3 halves. Since the slope is the same for each pair of points, again, the relation is a linear one, and the slope of the line is negative 3 halves. Example 3, we want to calculate the change in y and the change in x. So we found the first change in y to be 3 minus 5, which is negative 2. Change in x for those 2 points is positive 1. 0 minus a negative 1 is the same as 0 plus 1, which is 1. So we're going to ask you to copy the table above and calculate the remaining change in y's and change in x's. Pause as needed, resume when you're ready. So please compare your calculations with ours, make corrections as needed. Pause as needed here, resume when you're ready. Now calculating the slope for each corresponding change in y and change in x. Again, pause, resume when you're ready. So we found the slopes to be negative 2 over 1, negative 1 over 1, negative 2 over 1, negative 2 over 1. Right there. Not the same. Since the slopes are not all equal, this is not a linear relation. Example 4. Again, we need to calculate the change in y. We'll do the first one. Got change in y is negative 6. The first two, we got change in x is negative 3. 4 minus 7, negative 3. So go ahead and copy the table and finish calculating the change in y and change in x. Resume when you're ready. And notice all of these different values we've got here. Compare your calculations with ours and make corrections as needed. Pause if you need to do so. So now we'd like you to calculate the slope for the corresponding change in y's and change in x's. Pause as needed. Resume when you're ready. And even though the numbers look so different, the change in y over the change in x in each time is negative divided by negative, which is positive, and 2 in each case. Since the slope is the same for each pair of points, the relationship is a linear one, and the slope of the line is positive 2. Now you try some. Given a table of ordered pairs, decide if the relation is linear, and then if it is, calculate the slope of the line. Here's your first example. Pause as needed. Resume when you're ready. So here are all the change in y's, the change in x's in red, and when we divided each one of them, we got negative 1 over 3, or negative 1/3. It is linear. Slope of the line is negative 1/3. Press pause if you need to do so. Example 2 for you to do. You try one. Pause is needed. Resume when you're ready. Here we found change in y's in blue, change in x's in red, made the ratios, and nope, these two are not equal. The slopes are not the same for each pair of points, so not a linear relationship. All right, another example. Press pause as needed. Resume when you're ready. Here the change in y's in blue, change in x's in red. Make the corresponding ratios, and the slope is always 1/2. So the relation is linear. The slope of the line is positive 1/2. We encourage you to view video 4 about slope, which is derive the slope formula. Pause is needed here. Resume when you're ready.